All right, now we look at the normal approximation of data and let's start off with an example. So we're going to look at a population that is known to be normally distributed, and this is the height of men, and it's taken from a study called Haynes 5, which I guess is a survey of men in the United States done in 2003. All right, so the heights of men age 18 and over in the Haynes 5 study averaged 69 inches. So this is apparently the height of American men in 2003. The standard deviation was 3 inches. Okay, so the population of heights is normally distributed. And what we're going to do is then use the normal curve to estimate the percentage of these men with heights between 63 inches and 72 inches. Okay, well, there's two different ways that we can do this problem. One way I'm going to use is not using a calculator and essentially using standard units, first convert to standard units, and then second, using the empirical rule. Okay, so first of all, we have this information. We have given that the mean is mu equals 69 inches, and that sigma, the standard deviation, is sigma equals 3 inches. Okay, so this is method one. I don't know whether I should number it, but method one, not using a calculator. So the thing is that I'm going to use the empirical rule, but there's also tables that we can use, but I'm sort of avoiding those simply because we have calculators that do this. So I think a lot of people will not want to use this method. I'm going to use the empirical rule, but first what I'm going to do is step one. Oh, by the way, right here, what I'm trying to do is I'm trying to find the area under the curve where I have x, which is the height between 63 and 72 inches. So that's what we're trying to do. So we're trying to find the area under the normal curve with between those values. Now, see, we're assuming that we have normal distribution of height, and the mean is 69 inches right here. So I've been drawing the normal distribution with, it's called the standard normal distribution, where the mean is 0 and the standard deviation is 1. So this is not that. It's similar, but not exactly the same, because here we have the mean is 69. And so we have to the left of 69, to the right of 69, we have 63 to 72. So maybe, I'm going to come back to this picture and actually fill it in a little bit. But, so step 1, convert to standard units. And that's from another section that came before this. So we're going to use that z equals x minus u over sigma. So we're going to look at the endpoints of that interval. We're looking for the area between 63 inches and 72 inches. And so let me see if I can fit this all here. I'm almost done with this page. But if I have x equals 63, which is this left endpoint, then I have z equals x, which is 63 minus mu. Mu is the mean, 69, divided by 3, which is the standard deviation. And this will express this interval in standard units. So 63 minus 69 is negative 6 over 3 is negative 2. That gives negative 2 standard units. Now that I see negative 2 here, what this is saying is that 63 inches is 2 standard deviations away on the left from the mean. All right, that's what this means. It's 2 standard deviations. 63 is 2 standard deviations away from the mean, and below because it's negative. Now, if I look at 72, I get z equals 72 minus 69 over 3, which is 3 over 3, which is 1, and that gives 1 standard unit, which is 1 standard deviation. And so 72 is right here. And so what we're trying to do is we're trying to find this area right there. Now, it's true without a calculator, this might be a bit of a challenge, but we're going to do it. So in standard units this is what the whole thing looks like. Okay, in standard units, we have the mean is 0, and then here's negative 2, and here's 1. That looks like a z, make it look more like a 2. And this is standard units. And what we're trying to do is find the area. Okay, so this is almost like an intellectual exercise because we can use a calculator, but I'm still going to persevere here. The empirical rule says this is 68%. Now, that is the area as shown between negative 1 and 1. Now, if I take half of that half of that is going to be 68% divided by 2. Why would I do that? Because I want to get this portion right here that let me just color it exactly the same. So apparently then this part here is 34%. I guess I wouldn't expect someone to do this necessarily because it's not a step-by-step procedure I'm going through. I'm using the empirical rule, and we had another video and exercises on that, and I think it's sort of fun, but people often like step-by-step doing the same thing every time. Here you have to sort of look at this and figure out, well, how can I find this other region here? So this other region goes between -2 and 0. And so between -2 and 2 is 95%. So this region right here that's between -2 and 0, I'll color in the exact same color, is going to be 95% divided by 2, which, because it's not an even number, is actually a little bit of something to see. That's 47.5%. The thing is about all this also is that these are approximation. So that the total area, as we see from -2 to 1, is 47.5% plus 34%. I'll put 34.0 so I have my decimals all lined up. So apparently the answer is 81.5%. So conclusion, the proportion of men over 18 in the U.S., the United States, between 63 inches and 72 inches is 81.5%. This is an approximation because the empirical rule is an approximation. Okay, so that was pretty long-winded, and I have to say. So why don't I do something that might make more sense, is we're going to use a TI-83 calculator. So a lot of times math people have this sort of side to them that's not entirely practical. So because it's so cool that we can do this approximation just by using the empirical rule. So how did we do this again? Because these standard units are integers, so they're not fractional numbers, I'm going between -2 and 1. I look at from 0 to 1, which is half of 68%, because 68% is between -1 and 1. That's the empirical rule. So I get half of that is 34. And then I look from -2 to 0. Well, -2 to 0 is half of going from -2 to 2, so it's half of 95. Then I find that number and just add the 2. So it's just pretty cool that you can do that. But let's go into the modern world of TI-83. I think you can download the TI-83 app, or I'm sure there's other apps where you can do this normal approximation, just on your smartphone or something, but definitely on a computer, like a laptop or something. Okay, so we're going to do now second distribution. And I have, this might seem like this is an advertisement for TI-83s, and I have a whole rant I sometimes go on, which is I feel that we're moving more towards people carrying around their own laptop and tablets, and there's desktop computers, and those just seem more practical. I feel like they're easier to work with. The software can be easier to work with. But this is what we're using. I think a part of it is during tests, instructors don't want their students having an iPhone that they're using. Okay, so we go normal or second distribution to normal CDF. Don't pick PDF. So CDF, and then you enter that. And then, again, it's always good, and I really sort of, not just sort of, require that a picture be drawn so we can see what's going on as part of the getting some points or something on the test. We're trying to find this area under the curve. So under the curve, it's 100%. And this is the model is that we're assuming that the population has this normal distribution. And so under the area under the curve is the percentage of the population. So all the area under the curve is 100%. So from 63 to 72 is what we're trying to find. And so when you put those buttons in there and you get to normal CDF, what we're going to do is we're going to put 63 and 72. So the order is left endpoint and then right endpoint. And then we're going to put in the mean. And the mean is 69. And that's for this problem, for male heights. Apparently the average is 69. Standard deviation is very important of a population because it tells us how spread out the population is. So, so the standard deviation is telling us how spread out this population is. So what we're looking at is 2 standard deviations below the mean up to 1 standard deviation above the mean. How do I know that? From what I did when I calculated those standard units. So you put those in there, and after all this talking and work, I really hope it's going to be the same thing as the calculation I did by hand. Well, it's so satisfying. Okay, so this is 0.818 according to the calculator, 59, etc., 94 or 46784. I am going to round this off to 0.82 and say, well, that's 82%. Well, hold on. So this is a little bit different from what I have up here. I said 81.5%. I'm going to cross that out and just put 82%. So it was not that, all right, so this over here was done using the empirical rule, which are approximations. Approximately the area between -1 and 1 is 68%, between -2 and 2 is 95%. I took the half, added them together, I got 81.5%. Let's just round it to 82%, and then I get the same thing. Now, over here, this is a precise answer. So why would you want a precise answer? Because maybe you're doing real science and things like that in technology, and so you don't want to just have an estimate, but sometimes you do want an estimate and you want to be able to do it in your head. This problem is a little hard to do in your head, but if it were just, say, 1 standard deviation below and 1 standard deviation above, you could do it in your head, and it might be a good situation where you're, just sort of winging it with thinking about, oh, okay, approximately this. But if you want the exact answer, I mean, this is still a decimal approximation. It keeps going and going forever. It's because it's an irrational number, but it rounds off to 82%.